Okay, here's Module 2. We'll open up the text over here. You see this time I've got it separated out into lecture notes, lectures and notes, and the science papers for the analysis, but we'll get to that in a little bit. Okay, we'll go straight to scientific papers at nature.com. Here it is. Okay. Scientific papers are for sharing your own original research work with other scientists. At this stage of the game, I doubt you're doing a lot of original research with other scientists. That'll probably come when you get into grad school or your PhD. Okay, they are critical to the evolution of modern science, in which the work of one scientist builds upon that of the others. That's important. You'll see on a lot of these that they talk about what's already out there and what's missing, and they have to add on to it. Okay. They have two audiences. First, the referees, other scientists. The important thing about these papers is that they have to be reviewed before they get published. They're reviewed by other scientists who actually sign off on them. You can't just write something and get it published in a journal. They call them peer-reviewed journals, which gives them a certain status because other scientists have okayed it. There has been a bit of a scandal lately where they found some journals where scientists are just paying to have their stuff published before anybody reads it, which obviously is not good for anybody. So they have to be signed off on. That's why they're considered pretty valid. There's that word, valid. Okay. Papers that report experimental work are often structured chronologically in 5 sections. This is true across the board in my experience. Whatever area of science you're investigating, they all have this. Not necessarily the same terminology. They might call them something slightly different, but they're all in there. If you look closely enough, you'll find it in there somewhere. Let's scroll down. The introduction does fairly the same work that it did in 101. You have to introduce your topic. One thing you don't have to do on these is get someone's attention like you do at the beginning of a paper for 101. You don't have to grab them because they're scientists. You can't appeal to their emotions because they don't have any. So, first thing the intro does, it provides what they call context. You can think of that as background or history. They define terms a lot of times, which is a very important part of a paper. Make sure that the reader and you are on the same page when it comes to terminology. State the need. All research is done for a reason, basically to fill in a hole in prior research. Nobody can research everything. Nothing is finished. You have to say what's missing, why you're doing this in the first place, how it will help. And nobody cares if you're researching whether cats like salsa or punk rock, although that would be an interesting study in my opinion. But you say why it's necessary. You talk about your motivation, why you wanted to do it. State the need for your work as an opposition between what the scientific community currently has and what it wants, although basically what you think it wants. Then talk about what you have done in an effort to address the need. And then preview the remainder of the paper. That doesn't come up very often. I see it in less than half of these things. They will tell you what's coming up and in what order. Okay. Context and need. Scroll down a little bit. You'll notice they often say we. Very rarely do you see the word I in a research paper. We is because it's almost always a team of scientists. Even when it's one person, they'll often use the word we to keep themselves out of it. It's not about them. It's about the material, about the study. Action verbs. We applied. We assessed, we compared, we computed, we developed, we evaluated, we investigated, we modeled, we. Then, after the intro, you get to the body of the paper. The first part of the body is the materials and methods section. Science has to be reproducible for it to mean anything. If you're the only one getting the results you're getting, then you're not a scientist, you're just probably schizophrenic. You have to explain very carefully what you did and how you did it so that other people can do it too if they want to. So that's the materials and methods. You'll see this in virtually every single one of these papers that talks about an experiment. Oh, also, let me go back. I forgot something. In the intro, you will usually find the hypothesis. The hypothesis is the research question that they want to answer. They try to guess what's going to happen before they run the thing. It's called a deduction. You make a deduction about what you think is going to happen, and then you run it and see if your results, what they call the empirical evidence, which is the stuff that appeals to your senses, what you can see, what you can touch, what you can smell, if all of that evidence then agrees with your hypothesis or answers your hypothesis, that's pretty good. If it doesn't, then start over. Back to the drawing board, as they used to say in the old cartoons. Okay. After the materials and methods section, which usually isn't very long, you get to the big one. This is almost the entire paper. Results and discussion. First thing they do is lay out the results. Just throw it right in front of you. Numbers, statistics, differential equations, pie charts, graphs, x and y axes, answers to questions if it's what they call a qualitative study as opposed to a quantitative study. They don't say what they mean yet. Then you have the results and the discussion after that where they talk about it, what they think it means in the discussion section. That's usually the longest part of the paper, those two. The results section is often the hardest to read because it's indecipherable for the most part, but you can find some interesting things. The conclusion is very short, usually a paragraph, a very short paragraph actually. And in the conclusion, what they do is they don't restate what they said in the discussion section, but they talk about what's needed, what they have learned, and what's needed for the future. They will talk about recommendations for future research. If you'll recall from 101, one of the things you can do in a conclusion is to point to the future to keep the reader's mind moving forward. And sometimes they'll do that in a science paper as well. Like here. In the coming months, we will blah, 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 or one remaining question is, which is sort of passing it off to your reader to say, here, I'm going to give you the torch. Now you can go on and do this too, because frankly, we're tired of it and we're going to do something else. Okay. I don't know why they put this at the bottom of the page, but the abstract goes at the very beginning of a paper. It's the first thing you're going to come across right after the title. It's a single paragraph that gives you the whole paper, beginning, middle, and end, everything. It's written in the present tense. It's designed so that you don't have to read the research paper if you don't think it's going to help you. If you're doing research and you come across 100 of these research papers, you can't read them all. So the abstract will tell you exactly what they tried to do, what they did, and what they found. Everything. That's the abstract.